Imagine stepping outside late at night, far from the glow of city lights and the constant noise of daily life. You climb a quiet hill, stand still, and lift your eyes toward the sky. What stretches above you feels endless, a deep black canvas scattered with tiny points of light we call stars. It feels peaceful, even obvious. The sun has set, so naturally the sky is dark. That explanation seems simple and satisfying, but that comfortable intuition hides a much deeper mystery, one that has puzzled scientists for centuries. The darkness of the night sky is not as straightforward as it appears. In fact, it presents one of the most surprising contradictions in our understanding of the universe. If the universe behaved the way people once believed, especially in the time of Isaac Newton, then the sky should not be dark at all. It should be overwhelmingly bright. Not just slightly illuminated, but glowing intensely in every direction. Every point in the sky should shine with the brightness of a star, creating a uniform, blinding light. This idea might sound absurd at first, but it follows logically from an older view of the universe. For thousands of years, many assumed that the universe was infinite, static, and filled evenly with stars. If that were true, then no matter where you looked, your line of sight would eventually end on the surface of a star. It wouldn't matter how far away those stars were. Given an infinite number of them, there would always be one directly in your view. As a result, the entire sky would appear as bright as the surface of a star, with no dark gaps in between. Yet, when we actually look up, we don't see that. We see darkness, broken only by scattered points of light. This contradiction is known as Olbers' paradox, though you don't need the name to feel its impact. The real question is simple but profound. If the universe is full of stars, why isn't the entire sky shining? Why is there so much darkness instead of a continuous blaze of light? The fact that the sky is dark means something about our assumptions must be wrong. To understand this, it helps to think in terms of a simple analogy. Imagine you are standing in the middle of a vast, endless forest. Trees surround you in every direction, stretching infinitely far. When you look around, you see tree trunks. If the forest truly has no end and is densely packed, then no matter which direction you look, your view will always be blocked by a tree. You would never see empty space beyond them. Your entire field of vision would be filled with wood, with no gaps. Now replace those trees with stars, and the forest with the universe. If the universe were infinite, unchanging, and filled uniformly with stars, then the same logic would apply. Every line of sight should eventually hit a star, and the sky should be completely filled with light. There should be no darkness at all. But clearly that is not what we observe. The sky is mostly dark, not overwhelmingly bright. So something about that forest model must be wrong. The resolution to this paradox forces us to rethink the nature of the universe itself. The key insight is that the universe is not static and eternal in the way people once imagined. It has a history. It had a beginning, and it has been evolving ever since. Light from very distant stars has not had enough time to reach us because the universe is not infinitely old. There is a limit to how far we can see, defined by the age of the cosmos. In addition, the universe is expanding. As space itself stretches, light traveling through it is stretched as well, shifting to longer wavelengths and losing energy. Some of that light becomes so stretched that it moves beyond the range of visible light entirely, making it invisible to our eyes. Even though stars are shining, their light can be diluted or shifted in ways that make the sky appear dark rather than bright. So the darkness of the night sky is not a simple absence of light. It is a clue, a piece of evidence about the nature of the universe. It tells us that the cosmos is not infinite in age, not static, and not unchanging. Instead, it is dynamic, evolving, and still unfolding. The blackness you see is not emptiness. It is a window into the history and structure of everything around you. The next time you stand under a quiet sky and look up at the stars, remember that the darkness is not just background. It is a question that forced humanity to rethink its place in the universe. What seems calm and ordinary is actually the result of deep physical laws and cosmic history. The night sky is not just beautiful. It is evidence that the universe itself is far stranger and more dynamic than our intuition would ever suggest. Between those trunks, you see more trunks, and between those even further away, more trunks. If the forest goes on forever, no matter where you look, your line of sight will eventually hit a tree. You might have to look very far, but eventually flat, you hit wood. If the forest is infinite, you cannot see the sky. You only see a wall of wood. Now replace the trees with stars. If the universe is infinite in size, and if stars are scattered roughly evenly throughout it, and if the universe has existed forever, then every line of sight from your eye must eventually end on the surface of a star. Every single one you look at a patch of dark sky, no, you just aren't looking far enough. If you waited for the light to get here, or if you had a telescope strong enough, you would find a star there. Therefore, the whole sky should be covered in star surfaces, and since a star is hot and bright, the whole sky should be as bright as the sun. You might say, wait a minute, Richard, the stars that are far away are dimmer. They aren't as bright as the sun because of the distance. That is a very sensible objection. It sounds right, but let's check it. Let's be honest with the geometry. Yes, the light from a single star drops off. We know this rule. If you move a star twice as far away, it looks 1/4 as bright. It's the inverse square law. The light spreads out over a sphere, and the surface area of a sphere grows as the square of the radius. So the light gets thinner, it gets weaker. But here's the trick. Here is where nature plays a joke on us. While the individual star gets dimmer, the number of stars increases. Imagine a shell, a hollow ball around the Earth at a certain distance. Let's say it has a thickness of 1 billion miles. We count the stars in that shell. Now imagine a second shell twice as far away with the same thickness. Because it is twice as far out, the surface area of that shell is 4 times bigger. If the stars are scattered evenly, there will be 4 times as many stars in that second shell. Do you see what happens? The stars in the second shell are 4 times dimmer individually, but there are 4 times as many of them. The total amount of light coming from that shell is exactly the same as the first shell. Now add a third shell and a fourth and a millionth. Each shell contributes the exact same amount of light to your eye. And if the universe is infinite, if there are infinite shells, you have to add up infinite amounts of light. The sum is infinite, or practically speaking, it stops when the sky is solid light. So the dimness argument fails. It doesn't save us. The math cancels out perfectly. It's like a conspiracy of geometry. This creates a serious crisis because look around you. It is dark. So one of our assumptions must be wrong. Which one is the universe not infinite in space? Maybe. Is there an edge? A wall where the stars stop? That seems unlikely. Nature rarely builds brick walls in the middle of nowhere. Are the stars not distributed evenly? Maybe they are clumped. But we look out with telescopes, and on the large scale it looks pretty mushy and uniform. There is another possibility. People used to think maybe there is dust out there. Maybe there are dark clouds blocking the light from the distant stars. You know, like smog in Los Angeles. If there is enough dust, it would absorb the light, right? No, that doesn't work either. This is thermodynamics. If you have a cloud of dust and you shine infinite light on it, the dust will heat up. It will get hotter and hotter until it glows just as bright as the stars behind it. The dust would become a light source. You cannot hide energy. You can only move it around. So the dust explanation is out. So we are stuck. We are stuck with a paradox that suggests we shouldn't exist. This brings us to something very deep about science. When you find a paradox, when you find a contradiction between your logic and your observation, that is the moment you should get excited. That is where the treasure is buried. That is nature telling you you are missing a piece of the puzzle. The piece of the puzzle we are missing is time. You see, in the old days, and I mean the days of Newton, and even before everyone assumed the universe was eternal, they thought the universe just was, it had always been there ticking away like a perfect clock forever into the past, forever into the future, an infinite stage for the drama of existence. But this darkness, this simple dark night sky, it whispers to us that this cannot be true. The solution to the paradox is that the universe has not existed forever. The universe had a beginning. This changes everything. It changes the rules of the game. If the universe had a birthday, let's say some billions of years ago, then we are not looking at an infinite forest. We are trapped in a bubble. Light travels fast. It travels at a speed of 186,000 kilometers a second. That is very fast. If you turn on a flashlight, the beam hits the wall instantly as far as you are concerned. But the universe is big. It is surprisingly big. When we look out at a star, we are not seeing the star as it is now. We are seeing the star as it was when the light left it. If a star is 4 light years away, we are looking 4 years into the past. We are looking at a ghost. Now, because the universe has a beginning, there is a limit to how far back we can see. There is a horizon. Not a horizon of space, but a horizon of time. Imagine the universe is full of stars, infinite stars going on forever. But the stars only turned on 13 or 14 billion years ago. We can only see the stars whose light has had enough time to reach us. If a star is so far away that its light takes 20 billion years to get here, we can't see it yet. The light is still on its way. It is rushing through the vacuum, tearing across the cosmos, trying to reach us, but it hasn't arrived. It is like a letter in the mail that hasn't been delivered. So when we look up at the night sky, we are not looking at the whole universe. We are looking at a small sphere, a time bubble of the observable universe. We only see the stars that are close enough for their light to have reached us since the beginning of time. And because this bubble is finite, the number of stars in it is finite. There aren't enough of them to fill the sky with fire. There are gaps, lots of gaps. And through those gaps, we see the darkness of the nothingness before the stars were born. So the reason the sky is dark is because the universe is young. Isn't that a strange thought? 13.8 billion years seems like a long time to you and me. But for the purpose of filling the sky with light, it is just a blink of an eye. The universe hasn't had time to wake up fully. Now, if I stopped here, I would be telling you a partial truth. And I try not to do that. I want to tell you the whole truth, or at least as much of it as we understand. There is another factor, a factor that makes the universe even stranger. The universe is not just young. It is moving. It is expanding. This is something we learned from Edwin Hubble. But the idea is built into the equations of relativity. Space itself is stretching. Imagine you are baking a cake with raisins in it. As the dough rises, the raisins move away from each other. But they aren't moving through the dough. The dough between them is expanding. If you were a bug sitting on one raisin, you would see all the other raisins moving away from you. And the further away the raisin is, the faster it seems to be moving away because there's more dough between you and it to expand. This expansion does something very peculiar to light. Light is a wave. It's a wiggle in the electromagnetic field. It has a crest and a trough like a wave on the ocean. The distance between two crests is called the wavelength. For visible light, this wavelength determines the color. Blue light has a short wavelength, choppy, fast waves. Red light has a long wavelength, lazy, rolling waves. Now imagine a photon, a particle of light, leaving a distant galaxy and heading toward Earth. And it is traveling through space. But while it is traveling, space is stretching. What happens to the wave? The wave gets stretched too. The space it is traveling through is expanding, so the distance between the crests gets pulled apart. It's like drawing a wave on a rubber band and then stretching the rubber band. The wave gets longer. If the wave gets longer, the color changes. It shifts towards the red end of the spectrum. We call this redshift. If the galaxy is very, very far away, the space expands so much during the journey that the light gets stretched all the way out of the visible spectrum. It becomes infrared. Then it becomes radio waves. So the light from the most distant sources in the universe, the light that would fill in those gaps in the dark sky, is being weakened. It is being tired out. Its energy is being diluted by the expansion of space. So we have two things working together to save us from being cooked. First, the universe hasn't been around forever. So there hasn't been enough time for light from the infinitely distant stars to reach us. Second, the space is expanding, stretching the light that does reach us, sapping its energy, shifting it into invisible colors that our eyes can't see. This leads us to a profound realization. When you look at the empty spaces between the stars, are they really empty? No, they are not. If you had eyes that could see microwaves, radar waves, the night sky would not be dark at all. It would be glowing. There is a glow that comes from everywhere. It is uniform. It is constant. It is called the cosmic microwave background radiation. What is it? It is the afterglow of the Big Bang itself. Imagine the Big Bang not as an explosion in space, but an explosion of space. In the beginning, the whole universe was hot, dense, and glowing white hot. It was a fog of plasma. Light couldn't travel freely. It was bouncing around like a pinball in a machine. Then the universe expanded and cooled. Suddenly it became transparent. That trapped light was released. It started streaming across the universe. That light is still here. It is filling every cubic centimeter of space right now. It is raining down on your head as we speak. But because the universe has expanded so much in the last 13 billion years, that blinding white light has been stretched and stretched and stretched. It has been stretched by a factor of 1,000. It is no longer visible light. It is microwave radiation. It is cold fire. If you turn on an old television set, the kind with the big tube and the rabbit ear antennas, and you tune it to a channel that doesn't exist, you see that static, that snow on the screen. About 1% of that static is actually the cosmic microwave background. You are watching the Big Bang. You are watching the birth of the universe on your TV screen. So, is the sky dark to our eyes? Yes. But to nature, no. The sky is full. It is full of the oldest light in existence. We just don't have the biological equipment to see it. We are blind to the history of the cosmos unless we build machines to help us look. This connects to something very fundamental about how we perceive reality. We are trapped in our own scale. We live in a middle ground. We are not as small as atoms. So we don't see the quantum jittering, the craziness of the very small, where things can be in two places at once. We are not as big as galaxies. So we don't see the bending of space-time or the slow dance of the expansion. We are stuck in the middle, perceiving a slice of reality. Think about time. Again, I mentioned the universe had a beginning. This implies something about the structure of time itself. We tend to think of time as a river that flows. The past is gone, washed away. The future is yet to come. The now is the only thing that is real. But in physics, specifically in relativity, we have to change this view. We have to think of space-time as a block, like a giant sausage. Yes, a sausage. Imagine a sausage that represents the whole history of the universe. One end is the Big Bang. The other end is, well, whatever happens at the end. When we experience now, it is like we are slicing the sausage. We take a knife and cut a thin slice. That slice is our present moment. All the spatial arrangement of the stars and you and me is on that slice. But here's the kicker. Different observers moving at different speeds slice the sausage at different angles. If you are moving relative to me, your now is a different slice than my now. Your slice might tilt into my past or into my future. This means that the past and the future must exist just as much as the present does. They are just different parts of the sausage. When we look at the night sky, we are looking down the length of the sausage. We are looking back towards the beginning. We are seeing the layers of the sausage that were sliced billions of years ago. We are seeing a ghost world. The stars you see tonight, some of them might have burned out millions of years ago. They might not exist anymore on their current slice of the sausage, but we still see them because the light carries the news of their existence. And the news travels at a finite speed. We are always looking at the past. You never see the world as it is now. Even when you look at me, you are seeing me as I was a billionth of a second ago. It is unsettling, isn't it? We live in a delay. We live in a reconstruction of reality based on outdated information. But this delay is what saves us. If light were instantaneous, if the news traveled instantly, we would see the heat of the Big Bang instantly. We would see the infinite energy of the infinite stars instantly. We would be fried. The finiteness of the speed of light and the finiteness of the age of the universe acts as a shield. It keeps the sky dark. It allows the universe to be cold enough for atoms to clump together, for stars to form without being ripped apart, for planets to cool down, and for complex bags of water and carbon like you and me to walk around and ask questions. The darkness of the night sky is the condition for our existence. If the sky were not dark, we would not be here to see it. This is what makes nature both strange and beautiful at the same time. A simple observation, the fact that the sky becomes dark at night, can lead us, if we follow the logic carefully, to some of the deepest truths about the universe. From that single question, we are guided toward ideas like the beginning of the universe, the expansion of space, the finite speed at which light travels, and even the nature of time itself. It shows that you don't need complex machines or advanced laboratories to begin understanding reality. Sometimes all it takes is curiosity, the willingness to look at ordinary things and ask a simple but powerful question, why? But asking why is only the first step. The real challenge is having the courage to follow the answer wherever it leads. Often, the conclusions we reach will not match our everyday intuition. What we call common sense is not a universal truth. It is simply a collection of assumptions we build over time, shaped by limited experience. Nature does not adjust itself to fit those assumptions. The universe follows its own rules, whether they feel intuitive or not. And those rules reveal a reality far more dynamic and surprising than what we might expect. According to those rules, the universe is not static or eternal in a simple sense. It is expanding, changing, and evolving. It had a beginning, a moment when everything we see today was compressed into an extremely dense and hot state. This idea, known as the Big Bang, explains why the night sky is not filled with endless light. Because the universe has a finite age, light from the most distant regions has not yet reached us. And because space itself is stretching, much of the light that does travel toward us becomes weaker and shifts beyond what our eyes can detect. This is why the night sky is dark, and why we are not overwhelmed by the combined brightness of countless stars. If the universe were infinite in age and unchanging, the sky would blaze with light from every direction. But instead, we stand under a dark sky, not because there is no light, but because the universe has limits, history, and motion. That darkness is not an absence. It is evidence. It is the result of the universe expanding and evolving over time. So the next time you look up at the night sky, try to see more than just blackness dotted with stars. Think of the darkness as a signal, a faint echo from the earliest moments of the cosmos. It is the cooling remnant of an incredibly hot beginning. The spaces between the stars are not empty voids, but regions where space itself is stretching, carrying galaxies farther apart. The darkness tells a story of motion, time, and transformation, a story written across the entire universe. When you reflect on this, it changes your perspective. We are not separate observers standing outside this process. We are part of it. We exist on a small planet orbiting an ordinary star inside a vast and evolving cosmos. Yet somehow we are able to look up and ask questions about it. In a way, we are the universe becoming aware of itself, using human minds to explore and understand its own nature. That idea alone is both humbling and extraordinary. If this way of thinking excites you, if you enjoy taking simple observations and uncovering deeper truths beneath them, then you are already on the path of discovery. The universe is filled with mysteries, hidden in everyday experiences that most people overlook. By questioning what seems obvious and following the answers with honesty, you begin to uncover layers of reality that are far richer than they first appear. Share this perspective with others who think the night sky is ordinary, and remind them that they are looking at the aftermath of one of the greatest events in existence. The exploration is not finished. In fact, it is only just beginning.